All right, let's talk about the error that every single web developer has stared at in frustration. Today, we are demystifying CORS. I'm going to turn you into a CORS detective so you can stop guessing and start solving these things in minutes.
You know what I'm talking about. That infamous red text in your console that just stops you dead in your tracks. Now, it feels like a bug. It looks like a bug, but it's not. It's actually a crucial security feature doing its job perfectly.
See, the key thing to realize is your browser isn't trying to make your life difficult, it's trying to protect your users. And this error message, it's not the end of the story. It's actually the very first clue in our investigation. Okay, so before we can become detectives, we have to understand the law that the browser is enforcing. It's called the same origin policy, and it is a fundamental pillar of how the web stays secure. The whole security model is built around this one simple idea, the origin. Just think of it like a website's unique street address. It's made up of 3 parts: the protocol, like HTTPS, the domain, like example.com, and the port number. If even one of those is different, the browser sees it as a completely separate place.
So let's say your web page and the API it's trying to call differ in any of those 3 parts, a different domain, a different protocol, or a different port. Well, the browser flags that as cross-origin, and its default reaction? Block it. This is what prevents a malicious site you have open in one tab from secretly making requests to your bank account in another tab.
That console error is our first clue, but here's the catch. It is intentionally vague. For security reasons, the browser is never going to spill all the beans to your JavaScript code. So let's break down what it is actually telling us. So the console really just confirms that, yep, a block happened. But the real evidence, the why it happened, that's not in the message. To find that, we have to dig one layer deeper and go to the DevTools Network tab.
And this is where the real detective work begins. You see, for any request that might change something on the server, like a put or delete, or anything with special headers, the browser doesn't just blindly send it. First, it has this little hidden conversation with the server to ask for permission. This is called the preflight request.
It's like a 4-step dance. The browser sends this special options request asking, hey, is it cool if my website at this origin sends you a post request with these headers? The server then responds with the rules. If the rules match, great, the real request goes through. If not, it's blocked, and your actual request never even leaves the browser. This is where most CORS cases get cracked wide open.
And here's what that whole interrogation looks like inside your DevTools. It's amazing. You can literally see the questions the browser asked on the left, and you can see the server's answers on the right. If there's any mismatch here, if the server doesn't explicitly permit what the browser is asking for, that is your smoking gun. Okay, so now that we've gathered our evidence from that preflight request, we can start to identify the usual suspects. And here's the most important thing to remember. The fix for CORS is always on the server, never on the front end.
This right here is suspect number 1. It is by far the most common error you were ever going to see. It basically means the server just didn't answer the door. It didn't provide that master key, the access control allow origin header, to unlock the request.
The fix is actually pretty straightforward. You just have to configure the server to include that header in its response. You can either be very specific and list your exact origin, or if it's a totally public API, you can use the wildcard asterisk.
But, and this is a huge but, there is a critical trap here. If your front-end request is sending credentials, like cookies or an authorization header for a logged-in user, you absolutely cannot use that wildcard. The takeaway here is simple. If you're sending credentials, the server's response must name your specific origin. A generic wildcard just won't cut it. And this is a security measure, right? You don't want any random website to be able to make authenticated requests to an API on behalf of your users. So, what do you do when you're developing and you're stuck waiting for the back-end team to deploy a fix? Well, here's a little pro tip. You can use a local proxy tool. It sits between your browser and the server, and you can tell it to intercept the server's response and inject the correct CORS headers before your browser even sees it. This lets you get unblocked and confirm your front-end code works perfectly.
All right, theory is great, but let's put on our detective hats and apply all of this to a real-world scenario. We're going to walk through an actual support ticket and see how all these clues come together to solve the case.
So the case file lands on an engineer's desk. It's super vague. The payment widget is broken. That's all they've got. The investigation begins. First thing they do? Pop open Chrome DevTools. And boom, right there in the console is our old friend, the red CORS error.
pointing directly at a problem with the third-party payment API. So they immediately jump over to the Network tab, they find that failed preflight request, and the interrogation tells the whole story. The server's response is missing the most important piece of evidence. The access control allow origin header is just gone.
But wait, here's where it gets interesting. There's a twist. The engineer uses a tool like curl to talk directly to the API server, bypassing the browser entirely. And guess what? The server is sending the header correctly. This means the problem isn't the API, it's somewhere in the infrastructure in between.
And just like that, case closed. By following the clues from the console to the Network tab and then verifying with an external tool, the engineer didn't just find a bug. They pinpointed a complex CDN caching issue and provided precise, actionable evidence to exactly the right team.
So the next time you see that red error, I want you to remember this. Don't see it as a roadblock. See it as the first clue. Your browser isn't fighting you, it's guiding you. If you learn to listen to the clues it's giving you, you can decode any CORS mystery with total confidence.